this has got 4 American Indian patents. This just for your understanding that it's already recommended by IIT, already recommended by Minister of Environmental and Minister of Environment, Minister of Forest, Defence, Niti Aayog. All this has already been Minister of Drinking Water and Sanitation. So this has gone into the government documents in various places. So there is no question, there is no concern about the credentials. These are my team, these are my ecosystem. This is a different concept which I will speak some other time. That how we have in a city, we have several streams of transportation of sewage. We use grey water, different channel, storm water, different channel, and fecal sludge, septic tank cleaning, also another channel. So because of this dealing with multiple channels, what we finally end result we get that when there is a storm water drain, all these things people find it easy to dump there. The storm, because we have not created foolproof channels for all these things. So this is the concept about how to integrate and use just one utility channel. The entire waste can be transported in a single channel, that is through a vacuum transport. So we will discuss some other time. Today we want to discuss vacuum transport. What will happen is that the storm water will never get mixed with sewage and separated how much sludge is generated. Then I estimated, and actually going to the plant, that X is the amount of pollution in dissolved form, X is the sludge. So which means we are treated by this technology that we have not done any treatment, we have transferred from one phase to another phase. So that sludge has to go somewhere, pollution has to go elsewhere in a dumping ground.
Is this sludge as toxic as
more toxic?
More
toxic. Why? Because when carbon or sugar and salt combined form, organisms are able to deal with it because the energy comes from the carbon. Actually some biological reaction is happening. The moment you have taken out the carbon by removing BOD, COD carbon, you have enriched everything with the inorganic. So that actually is a breeding ground for mosquito, breeding ground for virus, and more breeding ground, because they don't need that source, they need this kind of source. So you have made it more toxic. If you run a sewage, if you run a treated water minus BOD, COD, you will find more mosquito visiting there. So therefore all this conventional technology which is doing partial treatment and ignoring the inorganic pollution are actually doing mistreatment.
Also in terms of electricity and other things also, if you can go ahead.
Even, yes, so the natural
aeration,
system,
electricity.
you have to provide oxygen to the aqueous phase for oxidation reaction. The only reaction they do is oxidation, nothing else. In my system I will talk about what other reactions happen. When you provide this oxygen, we feel that the biological reaction is happening because of oxygen we are providing and aerobic organisms are growing. But the situation, the hydrodynamic condition of the bed is such, reactor is such, that only few organisms can survive this kind of high shear rate at which oxygen is pumped into this, and turbulence. Natural organisms, not many genera will survive there. Only few select genera will survive. And that too, these are flood forming, slime forming organisms. That means we have the bandwidth in nature, we have reduced to only a select organisms, and therefore the capability of organism to detoxify is limited. And the energy which we are providing to sustain life inside water body, that is very, very high energy to sustain water, life inside water. That's how we get it from the logic of nature.
Can we see that slide where you have shown the both comparison between the conventional and the new?
I got your point of the limitations of conventional.
Yeah.
I got your point.
So then now we switch to, we said the aquatic system is no good. So we are switching, what should we do? Now whether there is any alternative, we are saying that soil or rock or the terrestrial ecosystem. There is aquatic ecosystem, there is terrestrial ecosystem, there is wetland. So different kinds of ecology exist. Terrestrial ecosystem in simple words is tropical forest. That means there is rock, there is topsoil and there is green plants. In the combination of ecology which creates the organisms and the rock minerals has lot of reactive sites. So chemically it is active, biologically it has wide range of organisms, microorganisms, macroorganisms to tackle different kinds of pollution. And the plant root also exudes a lot of enzymes. Whenever there is a pollutant, immediately foreign material. So the nature of the life is such that you try to attack it. So the possibility or probability of attacking that organism increases because of the biodiversity we create.
From that on, in tropical or equatorial ecosystems,
Yes.
diversity is less because higher activity.
Where?
Higher enzyme and microorganism activity. It is always lesser in equatorial and tropical ecosystems.
No, tropical
it
it is.
is.
Tropical it is the maximum biodiversity, then forest is the maximum biodiversity.
I'm not saying biodiversity, I'm saying biological activity is less.
No. It is in
Right? So how the enzymes, everything will be there in
the
tropical
plant
climate.
roots provide the microenvironment. If the topsoil is loose, then it will get washed away.
No, it will go along the different origins of the cell because of the heavy. That's what leaching happens. No?
Leaching happens if the biology is poor. If you
No,
look at
it's
the
a-
Kerala rainforest, why
In any rainforest, why we have Zamba, Zamba, what you call rock in Konkan, it is highly.
the concrete is a fractured because the strata is fractured, it goes.
No, any equatorial region, where you get heavy rainfall, there is always leaching. Aluminium and iron goes down.
Heavy metal, yes.
So humus is also less.
No.
Humus is always less in, it gets dissolved in water and goes down. So
Yeah.
I didn't get that point actually.
I will explain to you. As micropores, the reaction happens inside the micropores.
How it is related to the tropical or equatorial conditions?
Tropical is basically the heavy rainfall area.
That's what I'm saying.
Yeah.
No, how it is good, I don't get that. You just gave me the example, that's why I'm not able to link it.
I'm not able to get your root zones
Okay.
have a lot of enzymes which makes the micro environment more reactive for foreign species.
For?
This-
Foreign species.
Foreign If you don't have plants, I have huge diversity, the opportunity of biodiversity is there. Instead of one type of enzyme, you have many such microenzymes in the soil.
Okay.
And leaching happens when you have a poorly managed soil. If that, only when you have acid
No,
rain.
it is natural phenomena, if I'm not wrong.
Natural phenomena is there. Landslide, earthquake, everything is there.
No, I'm saying removal of the heavy material is a natural phenomena in high rainfall areas. That's what I'm saying.
Natural phenomena is because heavy metals are solubilized in low pH.
Exactly.
And low pH is if there is acid rain.
Yes.
If you look at Sweden,
Sesqui oxides are formed. I know
if you are
that.
Sweden or
The
Scandinavian countries,
plants in those countries have oxides, they form acids in the soil
yes.
and they get dissolved.
Even the rainwater has low pH compared to India.
Yes.
So therefore, even the rock itself has so much of ion exchange, so much of buffering capacity for acidic or alkaline layers.
Okay. So how it is used here? Like
So there are several components of the technology. One is media. This media engineering is all about selecting the right minerals and rocks at right degree of weathering, so that there is no, as you said, leaching and disintegration. At the same time, it has to be reactive, and there is a particle size gradation. Now, if you have a very highly porous, then contact will be less.
Right.
What will pass through. But if you have highly impervious, then your hydraulic loading comes down.
right.
That means you need more area for the same area.
Yes.
So therefore, it has to be a combination. That engineering is called media engineering.
Right.
That how we organize
So
the
silt soil clay kind of thing.
combination.
Combination of silt soil clay.
We have to ensure, and there is a rock, different layers, and we have to test the hydraulic properties and reactive properties before designing the reactor. The whole area comes under media engineering. Secondly, I said green plants. The green plants means it can be anything. but sometimes
I got the point, like plantation. Culture is some bioculture which
Yes.
will expedite the process.
yes,
Bio indicator is some indicator that will tell us
whether the system.
whether the system.
We were already accustomed to the terminology.
So what is it? These are just points, right? How
These
do you
are
tell
the-
the
Yeah,
what is the system?
Yeah, you go to the technology. That's what he meant to say. It's speed up.
So-
Yeah.
In practical application, you will have this on the left side. There is a primary treatment which all understand because the process is similar. There is floating solid, there is screening, then there is settling chamber, then there is oil and grease removal. All this you do it like a conventional unit. You will also have this. We have our own innovations. We will discuss in later. After the primary treatment is over, we will pump it through this called bioreactor, which is actually a confined ecosystem. That means there is a confined reactor inside which we have created this media and plants. Which looks like a garden from the top. So this is constituted the first bioreactor.
This will look like as a garden from the
From the
top
top it
view.
will look like a garden. I will come to those pictures. So essentially the schematically it's
I got this. Can you just tell me how it works?
Okay, so the pollution, if you consider inorganic.
No, suppose we will take this example only. Kitchen outlet, kitchen this kitchen and bathroom waste is collected in sewage collection tank. Now
Yeah.
what happens in your system? In bioreactor stage 1, what happens?
Stage 1, the first reaction is adsorption. Entire
Adsorption.
pollution is absorbed.
I don't know.
And then adsorption is
Adsorption by some rough material.
by the filter media.
Okay.
So that's the predominant process. Other processes are, let's say, precipitation, ion exchange. So different things happen. Predominantly, we want to narrate it. It's adsorption.
Okay.
And then in the adsorption is a very fast process. So by the time it reaches in few minutes,
It's mechanical.
so everything is it's a chemical process.
Adsorption.
Yeah.
It is a binding of two non-similar.
Physico-chemical process. It's a
Okay.
physico-chemical process, not mechanical. So adsorption removes the pollutant, but
Okay.
it is sitting on the surface itself.
Okay.
That means after some time,
It has to be removed.
it has to remove. So this removal job is done by biological mechanism. The biological oxidation
It removes that.
Yes. So
Okay.
therefore, you design in such a way that the rate at which the pollution is getting absorbed in a day, the rate at which it should react,
Removed.
then only you will have a sustainable system. The first reactor is almost 70% is removing,
Okay.
30% some pollutants require different kind of media. For example, microorganisms. You design the second reactor to trap the microorganisms, where the filtration rates are little
They
better. I mean, they little low.
bacteria
So
work
bacteria
on their own and they
Yeah.
disintegrate the different.
Yeah. So entrapment or
So there must be some anaerobic condition for this, right? So
not
there are
only
bacteria.
the media itself traps that.
Okay.
Mostly it is aerobic.
Okay.
Mostly it is aerobic. So the physical process
got it.
is better in the second reactor. So overall pollution removal is less, but the bacterial filtration happens
Okay.
better.
Got the concept.
So then
Tertiary, what is tertiary?
tertiary, primarily not exactly
So
tertiary.
first is adsorption and
Adsorption biological
biological
reaction.
then
Then within
bacterial activity,
bacterial
microorganism activity,
removal.
and then what is tertiary?
And tertiary is basically if you want to reuse that water for a very high-end purpose, like toilet flushing. So you would not like to see micron particles. So physically, if you remove submicron particles, not submicron, let's say up to 10-20 micron,
Okay.
then you need this. Otherwise, you directly put it on the ground. Because people complain when the ceramic particles get dusted, or you want to do a irrigation using sprinklers. That time it might clog. So you use this kind of system.
This is optional.
Optional.
So what is the output of this secondary stage? It is what is qualitative output like?
Well, you have to meet all the environment norms. BOD is less
So
than
it can
10,
be
COD less than 50, and without
the output
any
can be given to reverse.
Yes. It meets the reverse standards.
It means reverse.
Additionally, you are reducing the salt. The TDS also you are reducing.
Okay.
You don't require in norms, but you are reducing salts.
Okay.
And if you are reusing that water for, then TDS will build up. So So some removal is happening. At least you can infuse the fresh water to maintain the cycle.
Got it.
This is another way of representing the same
I got
process.
it.
And this is the cross section and
Yes,
primary
yes.
and secondary section. This is how the 3D model and a typical cross section of a reactor which
I think even today in today's treatment plants we use adsorption to create extraction.
Adsorption we do at the final polishing stage of using activated carbon.
Huh.
But the problem with activated carbon is that it doesn't react. After some time, it saturates. Then you have to dispose and that becomes a hazardous waste. But you look at the beauty that you continue to use this again and again and you don't have to dispose that. So adsorption, I have seen because personally hotels find it very difficult to dispose. It's so much stinking. And activated carbon is not cheap. And this is at the fag end of the process for minute, very low concentration pollutants or odor. That is taken care of with adsorptive process.
Basically, the core of this technology is the removal of the solid waste,
Dissolve pollutants, dissolve waste.
the waste that are there after treatment.
Yeah,
The removal of those
Organic and inorganic.
inorganic both.
Both.
And in the process there is no sludge generation.
हाँ, inorganic पे काम कैसे करते हैं मुझे
See,
समझना
the green plant, that is their food. When I said soil and rock, their natural appetite for high organics. So naturally it gets absorbed.
Inorganic.
Inorganic is picked up by the green plants.
How come? There must be some limit. Suppose there is arsenic,
Yes.
to some extent.
Yes.
Right.
Therefore we have to do the harvesting.
So,
biomass.
no. What I am saying, suppose, for example, the plants can absorb X amount of arsenic.
Right.
They have some extra 3x amount of arsenic.
Right.
The plants cannot absorb it. What about those 2x arsenic?
So
What do you do?
that will, if you are dealing with arsenic wastewater, especially for
No, I am just giving you an example.
correct. What you said is correct, but arsenic in liquid phase comes out when the pH is low. Okay, so when you use in plants, it is picked up. It is not in that
No, suppose
form.
whatever the capacity of the plants is over,
Yeah.
and it is more than that, then what you do?
I'm saying you have to trim the green plants, take out, then again it will grow.
So it is still that time it will be there in the water.
No.
Okay, how-
you have to
whether-
design. Let's say you have the
Arsenic is just one example. There can be n number of chemicals that are more than the plants could absorb.
Correct.
So how it is? I am not convinced with this part. Plants can absorb.
Correct. So what I am saying is that predominantly in sewage today we are discussing. If you are going to industrial,
So you are not talking about the chemical waste. You are talking about the sewage basically.
Sewage,
So what are the
basically.
standard
But industrial effluent specifically, let's say for leather industry, is full of chromium. So there are selective plants which can pick up chromium. You have to do actual experiments with those plants. No, even our basil. Basil is known to bioaccumulate it.
Right.
So the design has to be that at what rate it is able to. Then you require
Now
that much amount
those
of
plants become hazardous because they accumulate. It is accumulated in the plants, right? If it is
accumulate
not,
in the plant. It is not
because
to the level.
when you say bioaccumulation, accumulation is just changing from one soil to plants. It is still there.
It is
It
still
is not
there,
removed.
not in the form which is hazardous for the environment. If it is very low concentration in water, it is toxic for you. But if it is in the plant, it is
No, but it is still there, right?
it is there in complex form, in chelating ligand form. So it is not toxic. And you have opportunity to distribute that in so many areas. Like if you burn it as biomass, then you recover that metal again in ash. Okay. So we have delayed the cycle of immediate problems to biological and ecologically sustainable form. Other theories are there, but I don't want to discuss. There is something called
There are certain things which I'll discuss with him. Like he said about the arsenic, that's a different thing. I will discuss about it.
No, I was talking about
Where
the
there is no-
biological transmutation.
Yeah.
So that is a controversial theory I will discuss. So oxidation reduction potential tells us whether our bed is in negative or positive zone. So you can actually test what is the oxidation state of the bed. This is how we determine whether the oxygen has gone down or the work potential has gone down. This is some hydraulic issue we normally encounter. We have a better alternative by giving a radial design, large treatment plants. This is the micro, settling tank design, which oil and this thing is simultaneously removed. This is conventional on the left side. This is our high rate accelerator. And small plants we can do fabrication, but large plants we have to do in RCC. And this is an example how by managing properly sanitary chemicals we reduce the pollutant levels in the entire wastewater.
Now, as we
Yeah.
spoke, these are just the broad indicators. So, what are the actual indicators that have got reduced due to this technology? They are not
Test
reflected.
reports are there.
Sorry?
Test reports are there.
Okay, sir.
This is a disk filtration I was talking about. This is a different
Materials that could be used to make masonry RCC.
So you can
Choose as per the requirement.
conventional.
I'll just go through this. So, we can higher. When this technology was developed?
IIT Bombay,
When?
1990. My
So,
first
still
plant-
it is not used.
No, it's 20 years. It's in use. That's why I said 20 years.
No, where it is used, like any
Naval colony. 20 years is naval colony
naval colony
in Bombay.
Mumbai. There is Kulaba.
Kulaba, there is one plant, and there is a consumer, there is another plant.
Okay.
And ITC Taj Hotel from 2004.
They are using it.
We are still using it.
Low down
Sludge, greenhouse gas emission, nobody asked, but we promote it because this is our USP.
GNG कैसे मॉनिटर करेंगे आप सभी होकर? I'm just counter questioning just to know the things.
Yes.
How am I supposed to know that GNG is not?
From the chemistry, suppose I am doing an anaerobic digester perhaps. So anaerobic digester means 50% goes as ammonia, methane, 50% carbon dioxide. The carbon dioxide straight goes into atmosphere.
So it is GNG.
So then ammonia, in biogas no ammonia conversion happens. That will go into air.
But in our this bacteria thing,
Uh,
that might happen. So it may lead to GNG again. Previous.
No, because ammonia evolution will not happen. Ammonia is a physical evolution, as equilibria related problem. When there is a temperature and pH equilibria imbalance, it will go. In temperate climate, cold water, wastewater, it will go into atmosphere because of Indian climatic conditions. What I am saying that when it goes into our system, once it goes inside, then that evolution will not happen. The nitrification will start.
Okay.
And there is Anamux reaction, which is reverse reaction. So there are many ways nitrogen can be assimilated in the system. So that will not allow ammonia. Hydrogen sulfide, when you are maintaining high oxidation reduction potential, the anaerobic gases, anaerobic reaction will not happen. So you cannot say that there is a greenhouse gas emission because the pH is such, neutral. At the same time, the redox potential high. The anaerobic reaction not going to happen.
Okay.
In that sense.
And in case of maybe
One more aspect is that the carbon dioxide, which you might say, you are oxidizing, so carbon dioxide is going. But at the same time, we are compensating partly on the tree plants.
By planting trees, they absorb CO2.
Yeah. So
This
that is
is
partial.
this is much theoretical than.
That's partial. No, it's not theoretical. That is partial.
That is easy to understand, but
so that is what I was trying to intervene here. See, in conventional STPs, we are just thinking about when we talk about the greenhouse gases here, we talk about only carbon dioxide. But if you think in terms of the conventional, there is so many other things which is in the aerosol, which is much more soluble, and then it is
more than carbon. Methane is more.
methane and
carbon
others.
dioxide in terms, 1 in 20.
Yeah,
Greenhouse
sulfur,
gas, potential is high.
H2S.
Methane potential is more than carbon
Yeah,
dioxide.
yes.
Even in carbon dioxide, as you said, if you look at theoretical, a lot of sequestration happens in the rock.
Carbon sequestration.
Happens in the rock. We don't have wherewithal to measure that, because if you give a pollution control board says you all monitor what is off gases, then we will get first prize because we can definitely show that we are less than others. Right now we don't have that data, nobody asks for it, but theoretically we can understand. And we can also demonstrate that if you do a dome chamber test, you know, part of the reactor put a dome and monitor the gas. The question is who is now interested in GHG? We are struggling with the BOD and COD in most plants. Sludge.
If it could be done simultaneously, we should do.
We should do.
It has to be. BOD, COD is not the criteria at all. That is wrongly directed, and that's how all the designs are happening on the basis of BOD, COD only. Actually, we are not supposed to do that. Yes, please go ahead and show the further cost.
These are some other products. A single family SBT. This is Govardhan Eco Village where 200 kL we have done. On the left hand side, this is Baju Sultan tobacco. If you look at the special design where the wall itself is behaving like a photosynthetic surface area, and reaction is happening on the wall.
Absorption.
Green wall, where in a limited volume you have maximum surface area on the top, on the side. So you have more photosynthesis, more opportunity for inorganic pollution to come out.
Right.
And main thing we can see in terms of economy and environment, you can see how it goes hand in hand. Otherwise, here we see only all concrete structure and aerosols released and everything.
Compacted
How
structure,
aerosols are released?
those are not released. Because if you do aeration, from the top surface the particles are thrown out into the air when you do aeration. Because of the physical mass transfer. So when I said compacted as structure, this is the plant where I have done on top of garbage pile. Garbage pile has no strength. On top of it I have done this using special techniques, geo-reinforcement techniques. And this plant is there without any brick, cement or things like that. This is the wall you can see on the surface. It's actually a compacted earth and a membrane line on top of it. This is a conventional RCC tank, and without everything is on the soil with membrane lining on the bottom. This fully, this is again in
The complete SBT plant looks like this,
looks
fully
like a
blossomed.
garden. And you can use actually special plants for economic benefit. For example, fiber or
That is
lemongrass.
too utopian.
No, some.
No, that is okay. In theory,
No,
it
no.
would be really difficult for us to monitor if we put some plants
No,
here.
what one secretary in Belarus, MJP, he asked me, you give us some opportunity where we want to utilize that.
Chemical part.
Okay.
Getting my point? It also depends on the network
I
that is
understand.
collecting the sewage. If it has some chemicals,
Yes.
because in rainy season, the surface water may bring some chemicals to that. So in that case, will it be able to function?
Yeah,
One.
that's why this.
And second thing, will it be able to, handle 50 mld, 100 mld?
It's a linear technology. There is no limitation on the technology per se, but if you have space, we can have 5 ml, maximum 10 ml.
What is the ratio? Like for 5 mld, how much land you require? So if we talk in like per mld land requirement kind of thing
1500 all inclusive
for
1 mld square
square meter,
meter.
1500, 1500.
That has
So
all the
15,000 square feet.
office everything. Bioreactor हमारा जो
No,
है,
fine. So 1
0.8
gunta is 1 ml is 15 gunte.
हाँ.
Is it not very land hungry?
Vertical thing.
We can reduce it further. Why we are asking for
No,
this?
I'm just checking all the points, right? I'm just trying to.
No, very good
understand.
questions. Yeah, absolutely.
Because suppose our is 45 ml, right? One is 45, one is 9.
So I'll address that.
So both
question.
is 54.
I
No, I'm
understand.
just so it will require 10 acres of land.
It is not linear.
So I understood you will reduce few things when it is vertical.
right.
I understand that you will increase the height of the plant so that the.
Height up and
I understand that.
multi-staging. That one above the other also we can do.
But
there is a space.
वो आता आपल्याला किती लागते land 54 ml ला?
उसमें आपने वो 0.6 लगता है. बॉम्बे म्यूनसिपैलिटी में अभी लगाया है 0.6 स्क्वायर मीटर पर क्यूबिक मीटर. We are saying 1.2 to 1.5.
Okay.
So उसमें the sludge you are not considering that where you are throwing. So that
sludge
area you
काय
are not
करतो?
considering.
स्लज काय करतो आपण?
जाऊ दे मॅडम समोर नका समोर असतं मला.
नाही तरी काय करता ते तरी समजू द्या ना.
नहीं, उनका
स्लजचं आपण काय
problem- सबका
करतो?
problem है, वो क्या है?
हां कुठे घेऊन जातो मग आपण?
मैंने खड़ा हुआ था वो
दे विल नॉट से.
आयरोली में मैं गया था
अच्छा मैं